saying shit about people.
No, literally, you have like full on like coherent conversations with like everybody else. It's like your own reality show.
I want to film my own reality show.
That's literally what you do.
All right, so there are two type of general series, general sequence that you know. So sequence, there is arithmetic. That's with a story like 2, 5, 8, 11, dot, 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 dot. And this is called infinite sequence. So if we stop at a certain term, it's called definite sequence. Definite sequence. And if you dot, dot, dot is infinite sequence. So there was geometric, which is we're gonna do a lot more. So that is, like I said, it's 2, 4, 8, 16, 32. And geometric sequence is gonna happen a lot more. So this can be all written in formula. You learn algebra 1. You learn about, I don't know, the arithmetic is, so I'm gonna say arithmetic. Let's copy, paste. It's gonna be written in this format. Do you guys remember this? Do you guys remember this formula? It's from Algebra 2. You didn't pay attention, Marcos.
I'm playing Heyday.
You're playing what?
I do the homework like the second I get in the class and then play Heyday.
What is Heyday?
It's like a farming game.
I thought it was a cool math game. Cool math game back then.
I just play Heyday. It's on my phone.
Okay, so do you guys know what does D stand for? What does N stand for? What does A1 stand for? A1 stand for first term. D stand for what? Difference. Yeah, difference. Now, there's geometric too. Do you guys remember what geometric sequence formula is? Now, this is nothing to do with calculus. Just kind of review.
To the power of n minus 1?
Yep.
Oh shoot! Hey.
And we're gonna do this question. We're gonna do this later, but it just kind of built up for like what you learned in Algebra 2, even though most of you guys forgot. R is a common ratio. D is, so let me write down for you. So this D is called a common difference. So this is called common difference. And this is the common ratio. And the common difference is usually get by a to the n plus 1 minus a to the n. Why? Because your next term subtract the previous term. And the common ratio is going to be a to the n plus 1 over a to the n. So those are the common ratio. So for example, I can take this next term divided by this, then your common ratio is 2. 16 divided by 8 is 2. Is that okay? Now, there are other sequences that usually don't follow arithmetic or geometric. There are other sequences. For example, do you guys know this one? Do you guys know what is the pattern here?
You add 2. So it's 3 is 3, 5, 7, 9. You add 2 you add 2 to the difference.
Yeah.
Now, is it possible for you to write down something represent this sequence?
Oh.
I challenge you to write down something that to represent this exact sequence. So this is something that I usually test students. I see if they are good at this is a sequence I kind of I would have struggled a little bit. But how do you write it out though? Like, can you come up with a formula that represent this here? Can you come up with a formula to represent this same exact thing? Now, I'm gonna tell you that this is n equal to 1. So n is never negative. So n is always start with 2, n equal to 3, n equal to 4, n equal to 5. Right? So can you write out a formula represent this exact sequence using the idea of n? Is it possible? Yuri, you got it? No? You say it's possible. Anything is possible. So this one just a very random sequence. It's possible to write out this exact sequence.
Can I try?
Sure.
A to the n equals a to the n minus 1 plus a to the n minus 1 minus a to the n minus 2 plus 2.
What the hell?
No? Never mind.
That's kind of complex.
I probably just said it wrong.
That's kind of complex. Okay, how about then? Think about equation that is gonna plug in 1 is gonna be 0. Plug in 2 is gonna be 4. Plug in 3 is gonna be 8. Plug in 4 is gonna be 15. Plug in 5, that's gonna be 24.
N squared minus 1. Oh,
Oh.
yeah.
Yeah. That's
N squared minus 1. Think about it. If I plug in 0, I'm going to get, or if I plug in 1, I'm going to get 1 squared minus 1, 0. If I plug in 2, it's going to be 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, 5 squared minus 1. So that is an exact representation of this. Okay. So we are not going to deal with arithmetic sequence. We're not going to deal with geometric. We're going to deal with geometric sequence later. But a lot of sequence that we're going to come up with is not an algebra 2 sequence. It's going to be a little bit more complex. Okay, let's give you some notation. So here's the notation. So we're going to start with a sequence. So 9.1 is the sequence. And that's the pre-understanding. Usually sequence, what we're gonna do is we're gonna denote it as this. I don't know how to draw a brace, but this is a brace. It's a set of term. It says A1, comma A2, comma A3, dot 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 dot, to A to the n. Now, n has to be a positive integer. And can be denoted as this. As a to the n. And sometimes I can start with this is called lower boundary. So n equal to k. So I can start with the first number n equal to k. So n doesn't have to be start at 1. You can start at 2, but not negative number. So the term number can have to start positive integers, not negative integers. Okay?
Are those supposed to be curly brackets?
This is just brace. I don't know how to draw a brace. It's like this, I think.
Yeah.
I'm sorry, it's just I don't know how to draw a brace. I don't know how to draw summation either.
It is any including 0.
Now, this part, if it's not showing, n star at 1. If it's not shown, then it's going to be n at 1. So you can be 2 or 3 or 4. It can start at second term. It can start at third term. Right. So for example, I'm going to give you an example of one of the sequence that represents this. So, and I want you to write out the first few terms and just kind of see what happened, because we all know, like, algebra 2 in this school is not excellent. But you also never seen this before. So I want you to learn to write down what is A1 term, A2 term. Actually, sorry. When n equal to 1, n equal to 2, n equal to 3, and n equal to 4. Okay, what would it be, right? So you should be able to evaluate this number really quickly. Just had to plug in. Now, one thing you also see this new element here. This is something that we don't see here, which is -1 to the n plus 1. What do you think that do to a sequence? Like, what do you think this do to the sequence? It make you fluctuate, alternating between positive signs and negative signs, right? So this is kind of important because every even term is going to be positive. Every odd term is going to be negative, or r negative 1 to the power. So what do you think the first one is? It's positive. Okay, good. But what will be a number? What will be the an here? Okay, a1 is 1. A2 is what? -4/3, good. What's the A3? 2. And what's the A4? -16/5. Good. So does that make sense? Now we can write out those terms. I'm gonna ask you to do 1 here. -1 to the n of square root of n minus 2. And this is infinity, and this n equal to 2. What does that mean?
Is that like you're adding up every integer in between those 2 points?
No, you're not adding. Adding is called series. There's a difference between sequence and series. Sequence is just a pattern. A series is going to be adding. So what will be the second term? 0? Good job, Emil. Okay, so what is n equal to 3? -1. What happened n equal to 4? Square root of 2. See, in the future, in the past, if you see this pattern, you probably cannot tell what is it. What is the representing? But now you can start getting familiarized like what is going to be. So n equal to 4, n equal to 5 is what? Negative square root of 3. So this is A3, this is A4. Okay, now, yes. Oh, this is A2. Yeah, no, you're right. Wait, 2, 3, 4, I can count. 5. Okay, so is that okay? Okay, so the next question I'm going to give it to you is this one. So I'm going to give you a list of sequence. I want you to write out the formulas. So what do you think this formula representing? So we want you to figure out what the sequence, the equation, the sequence of the formula here. What would be the an? Some people can see it right away. Some people take a multiple try, and that's fine.
One. Square root of n.
N plus 2. Double square root of 1 plus 1. Or
And usually start with 1. That'll be easier to think about.
what it starts with
It's
0.
just n plus 1 over square root of n, right? Yeah, n plus 1 over square root of n. You get a 4.
It can't be 0.
So if you don't know, we're gonna start with the a1 is equal to 2. a2 is equal to 3 over square root 2. a3 is 4 over square root 3. a4 is gonna be 5 over 2. And if you see that this relationship of 2 and 1, it seems like is all adding 1, right? So here is we can come up with something. We also need to pay attention to, I can rewrite this 5 over square root 4. That's going to help you with something. So yes, and you're right. The equation is going to be end up to be n plus 1 over square root n. Pretty interesting sequence, right? The next one's a little bit tougher. But the next one, you need to know something else. Yeah, 120. This one's n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. I'm just gonna write down vertically so that would be easier to tell. You don't have to do this. Some people can see it, but
Each number.
I don't know.
Yeah.
Yeah, anybody got it? Good. One person? Marcos got it too? Marcos, Matthew approved. Okay. Anybody else? Something we haven't seen for a while, right? But doesn't mean it's not on it. It's definitely on it. So the trick is to write things out. I know, like, I'm very good with number when I was younger, and when I got older, I got dumber. So, like when I was younger, I can look at this, I can figure out right away in my head. But when I'm older now, I'm like, I don't know what this is. So I probably like I'll be more idiotic proof. I know it's probably gonna be some type of fraction. I'll just rewrite as 1. And I will say that is 1 over that 2, but 2 can also rewrite as 2 times 1. Does that make sense? And in order to get 6, how do you get 6? -1 to the 3 times 2 times 1. Right? And this is the one of 6. And so 6 times what? What's the next one? 24 is what? 4 times 3 times 2 times 1, right?
Oh, because it can't go.
And that's -1 to the
But it works for
5 times 4 times 3 times 2 times
it
1.
works for everything.
So we know the first term is going to be negative. So -1 is to the what kind of power? N or n plus 1? N. Because you want the first term to be negative. And on the bottom, it's going to be what? N factorial. Because 1 factorial is going to be 1. Right? This is equal to 1 factorial, right? This is equal to 2 factorial. This is 3 factorial. This is equal to 4 factorial. That's equal to 5 factorial. And that's equal to 1. By the way, 0 factorial is what?
Yes.
Oh, I was just doing.
What is 0 factorial? What is 0 factorial? It's actually 1.
Oh.
Okay, so let's get question. Like 24, right? 24 equal to 4 times 3 times 2 times 1, right? And the next number is 6. So what do I do to this number? I divide this by 4, right? If I divide it by 4, I get down to 3 times 2 times 1. I divide it by 4, right? Does that make sense? And this one is represent 4 factorial, and this one is 3 factorial. What's the next number? 2. So it'll be 2 times 1. So I divided by what? 3, right? Does that make sense? That's 2 factorial. I divided by 3. And next one, I'm going to divide it by the 2. So that's equal to 1 factorial is 1. And the 0 factorial, you're going to what? Divide it by 1. So therefore, it's 1 still. So 0 factorial is 1. And the 1 factorial is 1. Okay, so a little bit of,
One factorial divide just by 1.
which is 1.
Can you do that?
Well, yeah. You cannot divide it by 0. You cannot go to a negative number factorial. And they might have something, but I don't know about. So that's a very basic information, 0 factorial.
0 factorial?
I don't know what you're saying.
When you divide 1 factorial by 1, you divide 1 factorial by 1.
Yeah, so 0 factorial is,
So,
So-
you have 0 factorial, you divide 1 factorial by 1.
yeah, 0 factorial is 1 factorial divided by 1, yes. Because of the pattern. So if you think about it, that says from 120 is equal to 5 factorial. And 24 is equal to 4 factorial. But in order from here to here, you divide it by what? By 5. So you're going to,
By 5, because you can say like 5.
so this one is 120.
It's 0.
1 factorial. can you say like it's 1 times 0 factorial?
I know.
1 factorial.
But you have to establish what is 0 factorial first. But anyway, 0 factorial is going to be 1. I mean, that's just a very simple illustration why that is 1. But if it doesn't make sense, that's just, I don't know what to. You can probably find a better explanation somewhere. But that's the way I explain something.
Okay, so it's not dividing this side.
No, it's divided.
Okay.
So divide by 4 is divide by 3.
So 1 factorial divided by 1 is going to be 0 factorial. So that's according to the pattern. Because math is very pattern based. If you're going to see the pattern, usually that's how they invent math. But anyway, I don't know. Okay, so now let's talk about limits. Okay, so limits a sequence of a to the n has a limit. So sequence has a limit as different than series has limits. We are going to focus a lot more about series, but we're going to introduce a sequence first. So for me, when I tried to walk through the first time, I got confused when they talk about sequence and series. So sequence can have a limit, and the series can have limits as well. So there are two different types of limits. Series is adding each term, but sequence can have a limit as well. So if limits exist, then sequence convergent. If not, then sequence is divergent. And we're going to talk about what kind of divergent they are. But let's start with talking about property first. A very, very simple property that you guys need to understand. So property of thing, you know how important the math property is, but they are very intuitive. It's not memorization. So most of you guys can figure out right away. C to the A to the N is equal to C can be outside the limits. This is one of the things that about sequence. We deal with function before, but this time we deal with sequence. It's A to the N. Before we deal with X. Now it's A to the N. 2. Limits as n approach infinity of A to the N plus B to the N is equal to limit n approach infinity of A to the N plus, and they can be minus as well, so I'm going to write down minuses here. So limit x approach to infinity of B to the N. So they can be plus and minus. You can be also times. Limit n approaching infinity of A to the N times B to the N. And so it's going to be limit n approach to infinity of A to the N times limit n approach infinity of B to the N. Last one, of course, there's a division involved. So A to the N over B to the N is equal to limit n approach infinity of A to the N over limit n approach infinity of B to the N. But you have to, sometimes in the past, that you have to make sure that B to the N does not go to 0, because if it goes to 0, then it's undefined. Okay, 5. Limits as n approach to infinity of A to the N P is equal to limits of n approach infinity of a to the n to the p. But given in a to the n has to be greater than 0 and p has to be greater than 0. Okay, let me ask you some sequence. Are they divergent or convergent? So the first question, no, this one's easy. I'm just going to write down first. So is this converge or this is diverge? And what's the difference between converge and diverge?
Converges it goes to 0, diverges it goes to infinity.
Actually, converge has to go to a number. It doesn't have to go to 0. Because it can go become a number, right? So why is this one diverge? What is it called?
It's recessive.
Oscillating, yeah. So it's oscillating between -1, 1, -1, 1. So if it's not for sure into one number, right? If it's shifting to a -2, it's not fixated to one number. If it's not fixated to one number, then we're gonna call it divergent. Number 2. How about a to the n equal to 2n over n plus 1? Is this converge or diverge? Why?
As n approaches infinity, a of n approaches 2.
Good. How many way I can do that? I can use 2 ways, because if you go to infinity, it's going to be infinity over infinity. So what would be the first way? We learned originally in chapter 2. What do we learn the first way?
It's horizontal.
Horizontal asymptote, yes.
Yeah.
So what are you supposed to do with horizontal asymptote? You do n approach infinity of 2n divided by highest degree of denominator. Right? And if you do that, it's going to be limit n approach infinity of 2 over 1 plus 1 over n. That's equal to 2. So it's convergent. It converge. It converge into 2. The second way I can do is via L'Hopital rule. And of course, you don't have to tell me that, because infinite over infinity is the simple thing. So we just take a derivative of 2, n, and n is going to be 2. So that's still equal to 2. I just don't need to show you the work, because take a derivative of 2x is 2, take a derivative of x plus 1 is 1. So that's still equal to 2, regardless. How about this one? We want to know if they converge, we must put a limit in front of it. What do you guys think? Two plus -1 to the n power over n. What do you think this one is?
It's so dumb. It's 18. Converges?
Oh, it's gonna like oscillate, but reduce.
No, it won't.
Converge.
It'll converge at 0 though. Since this n approaches infinity, there's an
Oh wait,
numerator.
it's
It would like oscillate
Converge at
above
0,
0. It would approach 0 still.
it's gonna.
Does that make sense or no?
Squeeze down.
No? Okay. For example, let's use the most traditional way, which is we know if we want to reach infinity, we can divide it by highest degree of the denominator. So it'll be limits of n approach infinity. So that still counts matter. So it doesn't matter here. This is still going to what? If n approaching infinity, this is going to what? 0. How about this one? 0. So it'll be 0 over 1. So it's converged into 0.
And why is
Good.
It's only a day one or one. It's just 0.
Interesting.
oh
Does this make sense or no? If it doesn't make sense, let me know because I'd rather stop here, answer your question, then move on. Because this is a new concept. I just had to focus on teaching this part very well, then we should be on the way to get a 5. A to the n to natural log of n over n. Okay, we're gonna stop here.
And I might not be here. I don't know how many. I will have to.
What happened? You
I
got hit?
broke my jaw.
Why?
Of course, he did.
A horse hit you?
What?
Oh my god. I didn't realize until I looked. I cannot tell from that far, but
Yeah,
it
it's like all the way there. So I'll have surgery on Friday, and then I don't know. Could you record like
yeah,
everything? I will be here.
yeah, of course.
They will fix my. They will like. They will fix it. And they will
What's wrong with it right now?
It's broken right here. So one of the bones is here, and all this is like down. So I think so.
Okay. Well, I hope you feel better. I'm sorry that.
They will like put my teeth together. But we talk for
40 fucking
well, I will try to.
I got a cluster headache because of how much
I know.
Okay, I'll try my best. I mean, I'll record it for sure.
No, genuinely, I've never been that angry.
But yeah, I hope you feel better soon. Man, the horse must. That's why I don't like riding horses.
I wrote him like the day before, and I felt from him.
Worse, yeah.
Yeah, I have
The
a.
next day he kicked me.
He must be upset at you.
You weren't you on it?
No. I pretty much like the day before I was on him and I fell,
Yeah.
and the next day I
He's
came
mad
to
at your
see-
fall. So he-
Wait, so you haven't gotten surgery yet on your jaw?
Not yet.
Did you go to the hospital already?
Yeah, they just stitched it like right here.
oh my goodness. That's so
I was
painful.
supposed to feed him.
That's why I don't like.
Like he started to run, and I also started
Pretty
to run.
cool. I'm
So
so
he
excited.
just kept.
It's like
I wasn't like really behind him. I was behind but from the side. And, like this it was like 2 meters, so it was enough. I thought it was enough.
That leg must be really long. To
Oh,
kick
it's
2
big,
meters.
Really, for jumping, like he's jumping for. He do jumps like at competitions. He did that before.
Are you gonna do that?
Oh, him though.
You gonna post homework?
Yeah, not much. That's very easy.
Yeah. He didn't even come. Turning my back. I didn't see him.
Bye.
I heard you moved the pickup test to Thursday.
No, I didn't move. It's just off. Like the test is really bad. Like the stuff they do is like something else. I mean, to be granted, the question that they need to know, they know. But the question they don't need to know, they don't know completely. Like they don't know how to graph e to the x, which is like I'm more upset about that. Is like you can't even graph e to the x. So they will have a test again, but this test is gonna be added difficulty on it. Why?
I'm just trying to work on it. So you moved it from last Thursday to Friday.
No, we test on Friday. You can look at the test. It's bad.
No, I mean, yeah, but you originally wanted to do it on Thursday, and then you moved it Friday.
Yeah, because printer jam. But that's okay because I need to talk about some AP problem.
1 minute remaining until flat.
No big deal. They'll review it.
What happened?
You kinda like you gotta switch to glove into dude. Olsen's already giving me shit.
So this is like a new first day.
The first day you already give a shit.
Start new people.
Kind of true. I see what you're saying. I see what you're saying. Where's Austin? I know he's cool. I hear he was in physics today.
Yeah,
He was in
but you
physics
guys
today.
in Greenwald.
And Greenwald's not here.
He sent us the campus message at 4 in the morning saying that he wasn't going to be here.
You say what?
He sent us a canvas message at 4 in the morning.
Today.
Maybe you just don't feel like him to school.
He didn't elaborate. He couldn't.
I think he was partying too much over break because he said like he thought he was gonna be to school, but then like at 3:45 he realized he was not coming to school. He would messages, and he didn't assign work either, so I think he was just partying too hard.
I wonder how many people is gonna pass that AP exam. No one?
In our class?
It might be easier. It wasn't actually. At least my pass.
When do we take that?
Huh?
They're like, what the hell do you get this?
Not today, but Wednesday and Friday. For sure, Friday. Ping pong Fridays.
Like,
Are you good at ping pong, Anthony? Anthony might be secretly really good.
my parents bought ping pong tables.
I was so scared.
It's not even that far.
No, it doesn't matter. I was just scared. It's
Oh, jumping from the building? That's nothing.
it wasn't. It was like okay, yeah, it wasn't hard, but my like I could see the ground. You know,
It's not that far.
it was.
You gotta be
Even
like-
if you fall on the ground, you're not gonna die.
I want to fall. Damn, Irby showed everybody that video.
It shows the Irby's like backyard. He has like he has like a art shed and then like a
Oh, is he
carpentry shed next to each other.
He has a shed.
He jumped
Yeah.
crazy.
It's like a.
I wrote on the back of it, and he had like I don't think it's a bungee cord.
I feel like Irby is a wild kid.
He is a wild kid.
Yeah.
He's like on a skateboard. He'll attach a skateboard to the back of his ride around like.
He'll be that one kind of person just do everything that you can possibly think, like parkour or some stuff like that.
Pretty much.
Yeah.
I like Irby. He's nice. Nice kid.
Next time you're there, you should ask him to take you on a skateboard on the back of his
On a motorcycle?
Okay, guys.
four-wheeler ATV.
That
I-
day was enough for me.
ATV is fun. ATV is fun.
Very safe.
Yeah.
Are we doing math today?
Yeah, we are.
What do you think you're gonna do? Play some ping pong?
I'll beat all of you people.
What?
We should play.
Ping pong?
Are you good?
No, I'm not good. I wish I'm good. I have one eye. I can see the ball.
That press up to the point.
No, I
Oh,
mainly I bought it just for my kids because my son want to play ping pong, and I didn't want to put it in my house because like if you put a ping pong table in garage, you cannot park the garage anymore. And besides, garage is not big enough for ping pong table, so you have to have a big ass house in order to put a ping pong table. Huh?
Yeah, do you not have that?
I have a back like scrim pool isn't scrim, but I bought a ping pong table before, and I didn't know like Florida can ring anytime, and they have moisture, so that the top of the table is
Yeah, you need like
you should just
yeah.
get one that can fold and then like put it on the side of your wall in the garage.
yeah. I'm too lazy to do that.
no, we have a cup.
But yeah, I take a in Colonial, not Colonial, OBT has a place to play ping pong, and they charge like $24 for 3 people for playing ping pong. I'm like, ping pong, $24? I bought this table for like 150. So
Everybody gotta get their bread somehow.
I think it's true. But the core is used for a lot of them played what's that sports?
Pickleball.
Pickleball, yeah.
I'm also crazy at pickleball. I'll be anybody at any racket sport unless you actually play tennis. No
Last time I saw you play tennis, you suck.
problem. Okay. I haven't played tennis since like 7th grade, and I was still decent. Maya, they was beta. She said I could probably make up weights like versus tennis.
Really?
Not hard to do.
Yeah.
I know.
But
They suck.
they're pretty bad too though. Like for people who are actually tennis players,
I saw the girls is really bad. The girls are awful.
like I didn't want to say anything, but for people that actually play tennis, it's kind of
Yeah, I'm like that looks like a 3 months of playing. It's not even like no, Maya Beta is good, and they used to have Jackie is good. Shreya is good, and that's it.
at any racket sport. I'm crazy.
All right, we gotta see it.
I'll try. I'll be shooting badminton. I'll be shooting pickleball. I'll be shooting ping pong.
No, I can't play ping pong. I suck at ping pong. I tried to learn it when I was younger, but it never worked. But I'm trying to get my son to play. So I'm gonna bring him on Fridays to play.
You gonna leave school?
Yeah.
Pick him up.
Mom and big. So she probably have.
You don't like ping pong?
No,
Tennis?
You good at ping pong?
I'm self.
You should ask Irby. Irby's okay, but you should ask him how good I am at ping pong.
I heard Rogov's really good.
Is he? I need to play him. He was talking.
I heard Rogov would like be like Charlie like 20-0 or something. I don't know. But Rogov looked like he can be good.
Yeah.
Ping pong?
Yeah. I'm gonna say Rogov's pretty athletic. If he would have played basketball, I think he would have been fine too. He played soccer, he would have been fine.
Didn't he used to play soccer?
Yeah. He said he didn't make it on the team. Which is I'm kind of surprised.
A lot of Brazilians on the team.
What?
It's like a lot of Brazilians on the team.
Really?
It's like great in the DNA.
Yeah, the entire team is a bunch of Hispanic kids. There's like 2 white boys. Like Tyler Fritz.
But Nathan's not even on the team. But Nathan's supposed to be the best one.
He only plays club. The only team is so far beneath him. It's apparently his club team.
Pretty cool though.
But he's been like he would easily be the best player if he actually played. They're too bad for him.
Well, he's gonna go Spain to train for a week.
What's he about to play international?
Who is Nathan extension?
He's already get invite from like Duke and stuff.
Oh,
Crazy.
Yeah. That kid's smart and they can.
He has like a work ethic. He's very, very hard work.
He still suck at basketball.
He's getting better. His defense is good.
Yeah, because he plays soccer.
Yeah,
It's
he
like
plays offense.
you're not gonna run past by him. He's gonna stand in front of you. Oh. All right, so we're gonna talk about sequence and Jared, you cannot make it to the math competition.
Which there was
January
one-
27.
27. I think I've.
You do?
I can go to the other one.
Daniel will be there. Austin, you want to be there?
Huh?
Huh?
Science Olympiad is on the 27th.
Oh yeah.
Oh.
Anthony, you too.
Anthony, are you gonna be in Science Olympia or are you gonna be in?
A lot of the Science Olympic kids are skipping that day. Just go with the
I was
overlap.
like, they're skipping?
We're gonna go Vietnamese festival after that.
Like, I know, like, I'm on my partner for-
Last year we went to Vietnamese festival. Eden and
No, I'm not going to.
huh?
Nothing.
You'll fit right in. Of you of all people. Like we'll be an outcast. Bunch of Indian kids.
Hey, bro, we got destroyed.
I went to Seminole High School for a Molly UN, like, little
Yeah.
practice today.
Is that
It's
your
all
sequence
Indian.
stuff?
It's all Indian.
A little broken.
Model UN is good for college though.
Actually, it's crazy because I learned more at that like actual competition than I did at any of like the practices we've had. I just sat there and I just like listened to everyone. I didn't know shit. Like, I didn't know what was happening, and I was supposed to participate. The moderator, she kept looking at me because I was supposed to like raise my hand and I was supposed to participate and stuff. She was like, "Does anyone else want to contribute?" And then she would like look at me. I would be like, but yeah, no, like.
They're all going to that festival?
Yeah, that festival would be fun, right?
You too, Leslie? You're gonna go too?
All of
I'll
a sudden,
go.
I don't know anything.
Oh,
Oh, I remember last time I went,
Yeah,
I ended up
first,
some,
like-
like random like some party.
What do you do with the winning?
It's not even like we just walked around.
There's a gang.
Wait, Daniel was there?
Yeah, we all.
I didn't know Daniel was there.
Yeah, we
I didn't know you were there.
Me, Anthony, Sheldon.
The whole
Oh,
Oh, really?
Who was there? A singer.
Asim,
all four of us went.
Michael was, yeah. It was good.
Asim's cousin sent me a message today. So I was so random. So Asim's cousin sent me a message. I don't know where. So I was like, "Who the hell are you?" And she's like, "Oh yeah, my idiot cousins." Something. I don't know. But anyway, she said something pretty funny. Anyway, we're gonna talk about math.
You guys keep getting him distracted.
Yeah, I know, right?
First thing was just being
Shut up.
Look in the mirror or something?
You're gonna be homeless, autistic. Okay, so sequence.
I've never,
No,
I've
like,
actually never
Oh.
I've never,
like barely functional.
bro, what did they use? Look.
Non-verbal.
He
What
was,
do they call
no, he was very
autistic
verbal.
people?
He spoke a lot.
Okay, so we're gonna go through this really quickly because, I mean, we're gonna go through as much as we can. Sequences. In algebra 2, you should learn sequences, even though you don't remember anything in algebra 2. But you should learn two type of sequence. Do you guys know those two type of sequence?
Arithmetic and geometry.
Ooh, okay.
So, Miss Karate.
Who's your math teacher?
Miss Karate. Me and Andy were there. Miss Karate.
Arithmetic sequence, and she told us,
Anthony doesn't remember.
and they doesn't remember. Yeah, because it's fairly easy. So the simple sequences like this 2, 5, 8, 11, dot 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 dot. This is called arithmetic. The only things like about arithmetic is they have a common difference. Geometric is gonna have a common ratio. So for example, let's say it's 16, -8, 4, -2, 1, and -half. So this will be a geometric sequence, which is this one we're gonna actually deal more because actually later on we're gonna deal with something called geometric series, and we're gonna deal with this a lot more. But today we are only first day to deal with sequence. Oh, by the way, you guys saw the color chart. The color is where you stand right now. For us, as of right now, if you take an AP exam, I think that's what you're gonna get.
See, Andrew's already smiling. You can.
You got blue?
His ego is too big.
I know, right?
You got the blue. I'm assuming you got a blue. I'm assuming you got a blue.
Ellie?
Mhm.
Is that the name?
I saw the chart for the 6th period.
Oh,
I was like, one blue on there, bro.
Who?
For 6th period.
It's Shelly and Anthony.
You.
There's only one blue for 6th period.
Yeah.
But then, like,
A lot more green.
Yeah, I want to the new
It's
people
green.
are all important.
Yeah, you're green. You're
Yeah,
fine.
me too.
Is there one with exponents?
It's the only
You
class
did
we
it
have.
based off of grade though, right?
No, basic ability to be able to solve problems.
Let me see it.
Yo,
Is there a sequence with the exponents?
Huh?
Like exponents? Like 2 to the x, like that kind of thing?
Yeah. So there is a written.
I think Daniel told me the other grade. The box.
Fuck off.
Okay, arithmetic sequence. Is the formula is an equal to a1 plus d times n minus 1. You guys remember this formula? If you don't remember it, it's actually very intuitive. It's the first term plus the difference times n minus 1. Now, why is n minus 1? Imagine that if you have like a mile marker, right? And that this mile marker show up at here. This is 0 and start at this one is going to be the first mile marker, the second mile marker, the third mile marker, there's a fourth mile marker. So imagine that's like this. So this is going to be your A1. A1 in this case is going to be 3. Now, if you want to figure out if you want to figure out like says a to the what that says this is a to 1, a to the 2, a to the 3, a to the 4. You want to figure out what the a to the 4 is? Well, it's going to be plus the difference, which is 2, and then 4 minus 1. Why is 4 minus 1? Because if you have 4 trees, you have 3 space in between. So it'd be 4 minus 1. So you just only add 1, 2, 3 differences. So your final, the fourth term is going to be 3 plus 2 times 6, or 2 times 3, sorry, is equal to 9. So that would be at, wait, it's 9? Can multiply. Yeah, it's a 9. So it's equal to 9. So if you see this is 1, 2, 3, 4, no, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. So with this formula, you can figure out any term. Like you can figure out the 100th term. You can figure out 1,000th term, 1,005th term. Right? You can just use that formula, just multiply by n minus 1 times d. D is a common difference. Now the geometric formula is this.
Was it? I'm gonna guess. A1 over 1 minus r? Was that
No.
his name?
No. It's gonna be an equal to a1 times r to the n minus 1. So this is in geometric you learn in algebra 2. Now, of course, there are other type of sequence, right? So some sequence could be listed as like this. Well, how about this? What kind of sequence is this? Is this geometric?
It's like
5, 7, so it's
like
adding to.
it's like after.
So it's not really arithmetic. It's not really geometric. So the thing is, not all the sequence is always arithmetic or geometric. It could be different, right? Can you come up a formula represent this sequence?
Maybe like a general one or.
A general one, yeah. Is it possible to come up a formula represents this? Now I'm gonna give you some hint, right? Hint is this is the first term, n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. And this is called, this is also has a name, it's called A1 term, A2 term, A3 term, A4 term, and A5 term. Is it possible to come up with A to the n? So it turns out this is not geometric or arithmetic. Just some random stuff. Got it? Come on, Anthony.
Oh, wait.
I need to downgrade your color.
You don't get it, your turn.
He turned green. You'd be surprised who got it. Zayden.
It is a smart cookie.
Yeah, he needs a blue.
No. I'm gonna upgrade Zayden. Downgrade Anthony.
You know the one.
That's something Joshua.
Come on, simple math questions.
Easy question.
Easy.
We're all pretty dumb then. Crazy.
Oh, wait.
Come on, Daniel.
No.
Nothing?
I'll work it out.
How many different like operations are there per thing?
2 operations.
Oh, wait, isn't there like 2 different ways to think of it? Like recursive or
Yeah, there's also recursive, but recursive to write something like this is actually quite difficult. Actually, it might work with recursive better than a normal general term. But general term is actually easier, but it can work. Some of them is kind of hard. Like even recursive for all the even number is kind of hard to represent that. So
This is like.
No, I don't want her face showing.
all right, I'm gonna give it to you.
Wait. Is it, wait.
No, it's not. It's not.
It's not a hard. It's,
Oh, so.
it's not a hard. I don't know how long I'm gonna wait. Drink water.
Got it.
Matthew did not get it either.
When is this supposed to read?
Out like 4.
Mm,
When is it supposed to ring? Oh, great. That's the time I pick up my kid.
Will you like this day? Or you're just not here?
I don't care. Well, he's gonna have tornadoes or stuff.
No, it's really good.
for no watch.
Alright, well, let's not talk about this.
Yeah, we can do.
Should I give you a hint? You can figure out. We cannot wait here for 20 minutes.
Why not?
No.
Might as well pull out the ping pong table up here at it.
Yeah.
We can make it out of this.
Okay. I'm not gonna wait.
Wait, can you use the variable a of n minus 1? Right. Huh.
Got it, Daniel?
But I tried that, it doesn't work.
Yeah, I thought that was
If you're plugging one squared minus 1, 2 squared minus 1, 3 squared minus 1. 4 squared minus 1. Okay, so we got other stuff to teach. So let's just give you some idea about the sequence. They can be represented this way. So this is actually a nice color. A sequence can be denoted as this. Is a brace. I just don't know how to do a brace. A to the n is a set of term. A1, A2, A3, dot, 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 dot. N has to be a positive integers. And can be denoted as this. As a to the n of n equal to k. K is some type of positive number. And sometimes, most of the time, it's going to go to infinite. So if this is not shown, then n is always start with a 1. N start with a 1. If it's not shown, then n start with a 1. N start with 1. So usually you start 1. But you cannot be negative 1 term. That doesn't make sense. You can have a 0 term, which is sometimes it can happen, but usually it's first term. So, can you write our first 5 term for this one?
that mean at the bottom the not shown n equals 1 and
Huh?
like at the bottom n or not shown n equals 1 and starts with 1?
Yeah, so if this number, so for example, if I don't write here, this n is equal to 1. You start at 1. The first term start at 1, and this start would go and always, you could eventually go to infinite because that's your sequence is. Way. Can you write out first 5 terms? N equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. But here's the thing that's interesting. There's something you're gonna utilize a lot. What do you think that's gonna do to the sequence?
I'll make it a flip between positive.
Yeah, it's kind of like an on and off switch. So it's switch on, off, on, off, on, off. And you can decide what your first term to be negative or positive by using either -1 to the n or -1 to the, n plus 1 or n minus 1. So you can decide what you're going to start with. So usually you want to start with either -1 to the n if the first term is negative, or you want a second second term be the second term you can do -1 to the n plus 1. So your first term will be positive, second term will be negative. So if you work out, what's that? Oh. If you work it out, then your first term is going to be what? What's your second term? What is the third term? What's the fourth term? And last term?
16/3.
16/3, yeah. And this is the A1 term, A2 term, A3 term, A4 term, A5 term. Okay, so now I'm going to go to the next example, write our first few term. Now, this is the one example that doesn't have to start at 1. So you can technically start at n equal to 2. Why do they start n equal to 2 here? It can have a negative number inside the square root. So it has to start with the second term. So n equal to 2, a to the 2 is going to be what?
0.
0. N equal to 3 is going to be what? Square root 1, which is -1, right? N equal to 4. Square root 2. N equal to 5. Negative square root 3, right? If you just see this, can you do it backwards? Okay. So I give you 2 examples. Let's see if you can work it backwards. Here's one example. That what if I have a pattern is standard as this? Can you figure out what will be the general term is? General term of sequence? Like this one's pretty easy to figure out. So can you tell me what the AN is? You guys got it? Should be pretty easy.
That's on one.
Usually start at first term, right? Usually this is a first term. And dot 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 dot. So what I would you write it as you'd write it like this. I'll write it vertically so it helped me to think. sometimes this doesn't come intuitive for other people, but since they're all fractions, more likely this is a fraction. And more likely this is phi over root. This is gonna be 2. Now obviously this is gonna be 2 over 1, 3 over square root 2, 4 over root 3. This one can be phi over root 4, and this one can be root on all of them. So obviously this is exact same number term of n, so it'd be square root of n on the bottom. And at the top is always 1 extra more than the actual term, so it'd be n plus 1. So this one will be an equal to n plus 1 over root n. Is that okay? Pretty straightforward. They're not something very difficult. How about this one? New stuff. Well, not really new. Some of you guys should know what is this. What if I got a sequence like this? What would be the general term for this one? Today is Tuesday or Monday? It's Tuesday. Shit.
This is like going to.
Huh?
We're going.
We go into Taylor series, but we're not anywhere close yet. We're gonna start with all the different tests first. All right. You guys got it? New notation, right? So new notation says, this is A1. Let me write it vertically so kind of help you. But we know this is going to be a fraction, so it's be -1 over 1. A2 is going to be 1 over 2. A3 is 1 over 6. But what's relationship from 2 to 6? Right? A4 is what? 1 to 24. But what's the relationship from 6 to 24? A to the 5 is -1 to 120. So what's the relationship from 2, 6, 24, and 120? What kind of relationship is that? It is multiplication, but there's a better word for it. So let me write out more. -1 to 1. -1 times, well, 1 in order to get 2 is 1 times 2, right? -1, huh? 1 times 2 times 3, right? -1 to the 1 times 2 times 3 times 4. -1 times 1 times 2 times 3 times 4 times 5. But usually you write out a different way. So that is going to give you a factorial. Right? So a to the n equal to -1. But first term, it has to be negative. So it's n or n minus n plus 1. Just n, right? On the bottom, it's going to be n factorial. Because this is represent -1 2 factorial. This is -1 to 3 factorial. This is -1 to the 4 factorial. And -1 to the 5 factorial. Guys, do you guys know what 0 factorial is? Huh? 0 factorial is 1. I did talk about as 1. So imagine that 5 factorial is equal to 5 times 4 times 3 times 2 times 1, right? 4 factorial is what? 4 times 3 times 2 times 1. So in here to here, I divided by what? 5. So 3 factorial is equal to 3 times 2 times 1. So from here to here, I divided by what? 2 factorial is equal to 2 times 1. I divided by 3, right? So 1 factorial is equal to 1. So I divided by 2. 0 factorial, I'm going to divide it by, according to pattern, I'm going to divide it by 1. So that's still 1. So that's the pattern why 0 factorial is 1. Something kind of important for you to know. A lot of people, last period, a lot of people thought it was 0.
Don't you keep going?
Yeah, but I don't know what's like the factorial is. I don't think there was a 1, but they probably it was 1 because math is always like,
It's not the same pattern.
I don't know. Okay, so it turns out there was a new pattern, right? So you can recognize a new pattern. Any questions about this one? Okay, so they are also recursive, like we're gonna talk about tomorrow. Recursive is something that it's gonna happen like this. So we're gonna start with limits. Limit of a sequence. A to the n has limits. Limits of n approach infinity of a to the n. If the limit exists, then the sequence is convergent. If not, the limits is divergent. Now I'm going to talk about a property I already write down last period. I didn't want to write it. But if you finish writing this, we're going to write down all the property. And those property are intuitive. I mean, it's up to you to write it down, but they are pretty intuitive. But I'm just going to show last period's notes. Is there any question here? Okay. I'm going to show you last period's notes is talk about this. This is a property. So all the property of limits is limit n approach infinity of c to the an, which is constant multiplied by the sequence. The constant can be outside of limits. Now remember, before was a x, right? Right now, before was as a expression. Now it's an expression in terms of sequence that c can be outside. They still follow almost exact same rule. If limit n approach infinity of an plus bn, which is two types of sequence, the sequence can add together or multiply together or divide and even the power. So technically they are just same property as all the intuition operation that we learned in the past. They're not something that is different. So it's up to you to write it down, but I'm gonna write it for you, just in case that in the future you happen to use it. Okay, so we're gonna keep on going. So what happened if you have a -1 to the n? Is this divergent or convergent?
If there is a limit, it's divergent.
Huh?
If there is a limit, it's divergent or convergent.
Yeah, is this divergent or convergent?
I got you. If there is a limit, then it's is convergent. If it's not, so
Convergent.
let me get a divergent.
Why?
Because what's the rule of just one thing? You won't know at infinity whether it's positive.
Right, so you are oscillating between
Yeah.
two. Right, so you are equal to -1, 1, -1, 1, and it's gonna be like this. It's not fixated into something. There's no things, so we are gonna call this divergence sequence.
Divergent though. We mean like convergent is it gets to a value,
Mhm.
but wouldn't that be more of like a series? 'Cause if I remember correctly, series is you add everything,
Yeah,
but this is
this is what happened. Let's talk about what is your last number of thing. Are they gonna go keep on
yeah. Okay.
oscillating? It's not fixed into something. Let's just say if you go into infinite, but some of them are geometric. 1/2 times 1/2 times 1/2 times 1/2 times 1/2. They are geometric.
Yeah.
So that sequence will go into a 0.
Okay.
Right? So yeah, so very clear. So the first time I go into the calculus 2, the first year I taught it, and I kind of like was a student and teacher at the same time, and I get confused with when they talk about limit as sequence approaching this and limit as series approaching this.
Yeah.
They're two different things.
Yeah.
They're
Series
different.
for you said that would be 1, right? 1/2 plus 1/4.
Yeah, 1/2 plus 1/4.
But then sequence would be 0. It's,
Yeah. So what happened with this one? 2n over n plus 1. If I have a limit approaching infinity of 2n over n plus 1, how many ways I can accomplish this? Austin, first time you show up early, Greenwald's not here.
it should be 2 then.
Huh? Yeah, but there's two different ways to approach it. You have to know both ways. So sometimes, and the reason why it's kind of hard to do calc 2 is there are so many ways to approach a problem.
I like it though.
So they are obviously the first way is the most important way, which is limit n approaching infinity of 2n over n plus 1. I can divide everything by highest degree of the denominator. Do you remember that in calc 1? And since this is going to go to 1, this is going to go to 0, this is going to go to 2, so it's 2. So that's equal to 2. Second way is via L'Hopital rule. Since they are indeterminate infinite over infinity, so I can take d to the dn of 2n over d to the dn of n plus 1, right? Limit n approach infinity. So that's going to be 2 over 1. So that's equal to 2. So regardless which way, you're still going to get 2 separate way of limit approaching it. Let's talk about this one. It's actually interesting. So number third case is actually 2 plus -1 to the n over n. I have an an equal to this. Is this limit of the sequence converge or diverge?
Yeah. Limit approaching infinity.
Mhm.
Would it be 0?
Can you prove that's 0?
Can I say why I think it'd be 0?
Oh.
Is because at infinity, you just look at 2 plus -1. At infinity, -1 will be either it'll be -1 or 1. So it's the most it could be is 3 or 1 for the numerator, but denominator would be infinity, so it'd be 0. Does that make sense?
Yeah. Okay, so algebraically, I gotta be able to back it up though. Yes, that's logically, right? So that's a problem with the Calc 2 is a lot of things can be intuitive, but not a lot of people are intuitive. You are, Anthony is, but a lot of people are not. Me, I was intuitive when I was taking Calc 2, so I didn't have to think about too much thing. I always figure out a way to do it. But the problem is that's why a lot of people says not everybody can do Calc 2 because not a lot of people are intuitively able to do this type of stuff. And I'll show you one question in a second. So if algebraically, if I want to prove it, how would I prove it algebraically? You're right. It's going to be either 1 on 3 on numerator. On the bottom, it's going to go infinitely large. So it's definitely go to 0.
Yep.
So can I prove it algebraically, though?
It is kind of if you split up top, you've got like the range, or not yeah, the range. So the range is either 1 to 3. So like 1 to 3.
Okay, fine. 2 plus negative 1 to the n is between what value and value? What value? 3 and 1. The only thing is, I don't like that inequality is either 3 or 1 does not have any value in between. So you cannot, huh? You divide by n, yeah, you can do that. But the problem, like I say, the problem this, the slight problem with this is we're talking about a value between 1 to 3. But it's either it's 1 or 3. So it's kind of hard to write like that. No, you just divide it by everything by n. What will happen? This, when limit n approach infinity, 0. This is what? Negative 1 over n, 0. And this is 1. So 0 over 1 still equal to 0. So this is the sequence. Yeah, we're gonna finish this section today. We have
This works though. Like if you do, you can do all. Like if you take the derivative of negative 1 to the n, you get negative 1 to the n times ln of 1, which is 0. So it just be 0 over 1. Because ln of 1 is 0. Right?
if you take a derivative of negative 1 to the n, do you remember how to take a derivative of a to the x?
Yeah.
I would do it.
You do ln y on both sides, or ln both sides. Bring the n down.
So it's ln of a, right?
Yeah.
Times the a to the x, right?
Yeah. Wait, yeah, then. Well, the problem is
But
you
you're
get
gonna have
ln
ln of negative 1.
Yeah, you get ln of negative.
That's the, yeah.
Honestly, yeah.
So I will say this, the first way is better.
You just take out the
I know squeeze theorem it would work too.
How do you divide the n though over the like negative
1 over n, it doesn't matter. Negative 1 is fixated into one number now, right?
But that's
And if a bottom go to infinite, it's still gonna go to 0.
That's the same logic they used before. Like how to say proof is 0. Because it's still the same like intuitiveness that you need.
Yeah, I'm saying just what if the student is not intuitive there? And we have a lot of students. So for example, I will say there is a lot of students in third period not in sixth period is not intuitive. And it's not intuitive, you have to give him a things that how it goes. But you can also explain that intuitive way. If he gets it, he gets it.
When you do the negative 1 to isn't that also kind of squeeze theorem just on like
I think squeeze theorem will work better. I think you're right about squeeze theorem. The only problem if you establish squeeze theorem is, I think would have been fun. It would have been fun. I think this way is fun. Squeeze theorem like this
I know it's great.
will limit n approach infinity. This will be fun.
I was thinking that you do the same logic as when you divide.
Yeah.
No, you and Anthony did. After later.
Huh?
What's the video on?
At the end of the year, the seniors are gone. It's gonna be me and Anthony's.
And then Maya from
Isn't
Oh, beta, yeah. Huh?
Kyro Junior?
Right? It's-
Kerosene.
Man, everyone's. Wait, it's 6. Wow, that's interesting. Because I think it's just beta, right?
I mean, at that point, it's all beta. Honestly,
There's no point.
either beta means I'm sure the movie.
It's just beta and then YouTube. Wow.
I'm gonna be alone with beta. She's gonna talk to me so fast, and I'm gonna be like,
Double block.
huh?
We'll just create our own double block.
Yeah, I can't even like.
You're probably gonna say no.
We're gonna play poker.
Depends on how I do on it.
Just do it beta. Let me just. What was like that last year? Did you have like no juniors?
Yeah, I have like Paige left. Paige and Maria. Paige and Maria and Sydney.
Oh yeah, it came out. We were just playing.
Yeah, I only had 3 students left last time as well.
Well, this year you won't have only two.
What?
This year you would have had.
See that.
I feel like increasing every.
Nah, kids are taking dumber. Oh, it's gone.
Like.
What?
Do you think you could play of your pre-com
To skip only one student not able to do it. Neil Robinson. He would have been fine. Yeah, Neil Robinson will be the only one person that able to get it. Skip like pre-calc. But even her, I think. No, I think she's slightly better than Beta. Yeah, she's slightly better, but what else that is good? Aiden, Daniel's brother is alright. I don't think he can skip it.
Do you do the same coding thing for your pre-calc class?
Well, my friend said you showed our charts in pre-com. Apparently, you can talk about it.
Yeah, well, we're talking about just like the people who can figure out how to do something without people being taught. Like it's not like you don't have to teach them to figure out how to do stuff.
You don't think I can get a 4 on AB?
Huh?
You don't think I can get a 4 on AB?
Did I give you a red color?
You gave me yellow.
Huh?
You gave me yellow or orange.
I'll give everybody yellow. I don't know. Right now, you're probably gonna get a yellow, honestly, because we don't go through enough FRQ for you to know what's going on. But I think at the end of the year we should be fine.
But did you rank him in AD too?
Yeah, in in AV, I don't give everybody more than yellow.
You don't take that.
Oh my god.
No fucking way. Yeah, he's a garbage bag. No way.
Yeah, one day somebody's gonna get smashed, and that'll be a lawsuit right there.
I mean, I would assume they look. No way.
No, one day I'm just gonna. If I want to quit my job, that's the way I'm gonna get out.
Wait for it to go.
Yeah, I'm just like run out. I have a camera on the top, and wait until they throw it. I just purposely walked into it.
I know.
I would like break my knees and like break my neck. So.
Yeah, can we get our class back? This is some homework, it's on the test.
Yeah, but there's one extra pages.
I know. I already take a picture of my phone.
Yeah, I graded halfway. It's so shitty, so I don't want to grade more. I was like, I get depressed when I'm grading those tests. And I don't. I'm anti-depressing. Austin's gone.
He didn't catch up on sleep over break.
He's actually talking.
I don't want to show you a test because, but I will show you the answers. But you can look at it.
I didn't know he had but it's kind of weird. Yeah, I think that's pretty cool. I'll figure it
Yeah, I graded halfway, and I was like, ah, this is not the first thing.
My handwriting maybe that's
Oh, that's not yours? Who's that? Oh, Oscar. You know, you do some stupid shit like you usually do. Julia. Yeah, Julia, this is really bad. I won't even look at it.
The poor, I know, I did wrong. I know, I don't know, how?
3 hours.
I don't even know what I did on the second one.
You should lay down in the bag and just knock out. And I will leave without telling you. Yeah.
Last time was like the first time I slept
Boom is on time.
I was gonna go to sleep at 12.
I popped like 2 months.
I should have.
That's what
Witcher 3 is just like.
I wanna go home too.
We're gonna drive home. Yeah.
Do we have homework?
No. Today will be easy.
I'm just gonna watch the video.
This is pretty easy stuff.
I already watched it before. You recorded 6 minutes, right?
If I stay here like 5 minutes past the bell, it's not even worth leaving now. I just wait until the parking lot gets there. Like, no, there's no reason for me to sit there for 15 minutes.
You just park in the senior bar.
Do they check?
I mean, I think as long as you have like a pass.
I know, like,
Sometimes the-
you know how there's a black, I think he's a security
Oh,
guard
I have
and a
that.
coach.
So I'm just not.
You know what I'm talking about?
Coach Gabe.
Huh?
Coach Gabe.
A black guy?
No, I don't think it's.
And he gave me a hard time last time at parking on the senior parking lot.
Is it the security guard or Coach Gabe?
I think it's not a football coach.
What's security guard?
I think he's a security. Is it?
Oh no, he has last name.
Yeah.
Yeah.
He gave me a hard time. And he's like, this is student parking lot. Teacher not allowed to park here. I'm like, okay, you go ahead and tell it. I don't give a shit. I don't walk away.
It's not gonna make a difference. Like,
Yeah, it's not full. And the guy trying to give me a hard time. I was like, if I'm black, you're not gonna give me a hard time. That's because I'm Chinese, you give me a hard time.
you said that?
Huh?
You said that?
I wish I would have said that to him. Like, for real, if I'm black, you won't be like, you would be perfectly okay.
Actually, I don't know. I don't know if that's. He's just probably like strict on rules or something.
They're trying to give me a hard time. I'm like, dude. And he went to told the principal. The principal right night. He's like, this teacher park over there. And they're like, the assistant principal is like, is the parking lot full? He's like, no. I was like, okay then.
They said that?
Yeah.
That's gotta be so hard.
Yeah, but the parking lot's not full. It's like if it's full, I understand. Like you're being strict on the rules.
If we tried to do that,
Which assistant principal?
He likes me. Brad Shefford.
Oh, I thought he didn't like you.
No, he's all right.
I
Oh,
thought
he's
that-
the one that write everybody up
Yeah,
last time.
last year. Yeah. I thought he didn't like you.
No, he liked me this year. I think he never saw my result before, and he was being asked.
But
But
then
like-
I like the 98%.
Yeah, because now he's the API. API is the one that handle the class schedules, like which teacher got which assignments. And he see my result, and he's like,
He does his job. He's on.
and that's why he was like, dude, it's a parking lot. It's like, I hear the conversation, I just laugh and I walk away. I think in total, the car's only worth $4,000.
yeah.
And it's probably not even worth for me to go pick it up. So I'll just buy a new car.
Did they put a boot on it?
Huh?
Did they put a boot on it?
Again.
What?
I already buy that car in Craigslist. I look up Craigslist. This guy was selling for $3,850. I still don't remember the price.
We gotta go home.
Oh,
Yeah.
okay.
All activities means all activities, even if y'all are working and tutoring. I'm sorry.
Oh,
It's gonna get really bad out though, so I want to make sure you guys get home safe.
okay. That's
Okay.
fair.
Thank
All
you.
right. I'm just trying to work overtime. You don't
I
want to make it
know,
work.
I know. You guys can meet virtually. You can get to your house and you can go on Teams. Remember that? Right? Remember how to get on Teams? You can do that. We could go to 2020. You get to go home early. Look at that. They can bring you on virtual. I know. Appreciate it. But I also want you to get home safe to your family.
Is that bad?
Yeah, it is that bad. We're under a tornado watch right now, but there's a big squall of storms coming between 4 and 7. So, my husband works for the sheriff's office. Their main building. Of course, the guys are all still out on patrol, but they sent all the extra secretaries and support staff. Yeah, so it's pretty bad. So they're all the after school activities, including tutoring, practices,
I thought just like football and stuff.
No.
I read a little bit. I thought like football or tennis.
No.
That makes sense. Oh,
even
okay.
our school tutoring that we pay the tutors is canceled. So everything, but even other businesses outside of school are closing. The other counties got out earlier too, Lake County got out early. Marion County is closed. So yeah.
I didn't know how serious it is. I was like,
So
I look at it it's like, it's not raining.
I know, right? Oh, it's just a summer thunderstorm.
All right.